Hi everyone. This video is going to teach you how to use the difference of squares patterns to factor polynomials. You may have already seen this with some quadratic functions, but now we're going to use the same format and extend it to polynomial functions. We're going to factor the following polynomials. Any polynomial falling into the difference of squares pattern will look like a squared minus b squared. The factored form will then be a minus b times a plus b. To convince ourselves that the pattern works, we can just multiply out the factored form. We double distribute, first distributing the a and then distributing the minus b. Once I distribute, the plus a times b and the minus a times b in the middle will zero each other out, leaving us with a squared minus b squared. We start with a simple example, x to the 6 minus 36. First, I have to notice that x to the 6 and 36 are both perfect squares. So this one looks like it follows the a squared minus b squared pattern. What I need to find is something squared that gives me x to the 6 and something squared that gives me 36. X to the third squared is what gives me x to the 6. Remember that when you raise an exponent to another exponent, the shortcut for that is to multiply the exponents together. And then 6 squared is what gives me 36. Now I can just put those values into the pattern. So the part of the pattern representing a is the x to the third. The part of the pattern representing b is 6. And so I just put both of those into the pattern. So the factored form is x to the third minus 6 times x to the third plus 6. Again, you can check this by distributing it back out. You'll notice it's x to the 6th because we add the exponents. X to the third times x to the third is x to the 6th. 6 times 6 is 36, and the plus 6x to the third and the minus 6x to the third in the middle will zero each other out. So in summary, notice the perfect squares and that they're being subtracted. Find what number squared would give you each of the values, and then put those into the difference of squares pattern.